Hello everyone. My name is Kunal, and I'm your mathematics tutor. And we are doing actually definite integration. And today is the lecture number 9, which is the last lecture on definite integration. तो हमने अभी तक जितने भी टॉपिक कवर करी हैं, प्रॉपर्टी सारी प्रॉपर्टी कर लिया, सारे थ्योरी जान लिए, सारे प्रॉपर्टी के इम्प्लीमेंटेशन सीख रखे हैं हमने, एंड कल की क्लास में हमने डेरिवेटिव ऑफ एंटी डेरिवेटिव भी सीख लिया. एक टॉपिक बची हुई है, एक्चुअली 2 टॉपिक बची हुई हैं जो अपन आज लास्ट लेक्चर में कवर कर रहे होंगे. एंड देन फ्रॉम द नेक्स्ट क्लास, फ्रॉम द नेक्स्ट लेक्चर वी आर एक्चुअली डूइंग एप्लीकेशन ऑफ इंटीग्रल. हमने जो भी अभी तक इनडेफिनेट इंटीग्रेशन, डेफिनेट इंटीग्रेशन पढ़ा है, उसकी रियल लाइफ में एप्लीकेशन भी तो होती होगी ना कैलकुलस की, तो वो अपन नेक्स्ट क्लास में पढ़ रहे होंगे. ओके, सो लेट्स बिगिन आवर today's lecture, which is mostly based on definite integers as a limit of a sum. So let's begin our topic. Okay, so let me write the topic name first. So our topic based on definite integral as a limit of a sum. Okay, so this is our topic, like definite integration as a limit of sum. So what we have to do and in which form problem is given. So let me show you the form of integral and form of question. So the form of question, as mentioned here, it is definite integral as a limit of a sum. So there will be limit and there will be summation and there will be integration also. So let me show you the form. So it will be like we are expressing the series. In form of, it is little bit theoretical, but yeah, it is important because it's a mostly asked in JEE mains and JEE advanced sometimes as well. Okay, so the series in form of like it's look like something limit and tending to infinity, and there is summation. You all familiar with summation? I already tell you what it is. It is basically we are adding from 1 to n or whatever term. Basically, like okay, you all are familiar with this. I already taught you in, I guess, lecture 7 or lecture number 7 or 6. So please go through it if you don't know this. I hope you'll all read this in like sequence and series chapter. So you all are familiar with this. So no need to worry about. So 1 by n and f of r by n. F of r by n. So actually, whatever written in our summation form, we convert this series into this format. Our prior work is like to convert the series in this format. Then what we have to do, this is actually the theory part. I will taught you its implementation just after that. Okay, so this is just the theory part. You have to use it. So let me explain you what I'm trying to say. First thing I have to do, whatever written in series I here, we have to convert it into this form, right? And then what we have to do, we have to replace r by n 2x 1 by n 2 dx and summation by integration. Now here comes the integration, right? Here comes the integration. So there will be some value like upper limit, lower limit. So we have to calculate the lower limit. So how to calculate the limit in it? Let me write here how to calculate the limits in it. So how are we gonna calculate the lower limit? So our lower limit is nothing but limit, which is something called a. So limit n tending to infinity r by n, and where r is the lowest term in series. Okay, where r is the lowest term in series. What is the upper limit? I will, when we learn its implementation, so you all, everything is clear to you. So don't worry. This is just the theory part which I am trying to write you. That's why Like अगर कहीं भूलो तो तुम्हें याद रहे. Like, are you getting now? So like limit n tending to infinity r by n, but this time where n is the highest term in series, right? So this thing we have to do. This is the basic theory part. First, you have to convert the series into this format. Then you have to replace r by n to x, 1 by n to dx, summation to integration. And then it's time to limit put the limit in the integration. So for lower limit, you are just doing limit n tending to infinity, r by n, where r is the lowest term in the uh, summation part. And for upper limit, limit n tending to infinity, r by n will be the, and where actually r is the, this is my r. So let me write in a clear way. So this is r. Okay, let me erase it. And okay. So this is actually r. So it is the highest term in the series. Okay, so I hope you'll all understand this, what I'm trying to say. So how it's our actually this term is look like. So let me write it here. Our limit n tending to infinity, and then summation from r is equal to a to b, right? Uh, Actually, it is 1 by n dot f of r by n. It's something look like our integration from a to b fx dx. We have to convert this into this format. Let me show you how we do that. Okay, so okay, so let's take an example here, and we learn how to implement this. Okay, so let's take the example. So let us suppose our series is given. It's something given like n tending to infinity, 1 by n plus 1 plus 1 by n plus 2 dot 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 1 by 6n. Okay, so this is our series, right? So this is our series, and first we have to write into this format. So let's start writing here. So limit n tending to infinity, we actually write in form of summation 1 by n plus r, where r varies from 1 to 5n. Why 5n? Because look at this term. We can write 1 by 6n as 1 by n plus 5n. Okay, so our r varies from 1 to 5n. I hope you'll all understand this, what I'm trying to do here. Now, what you have to do, you have to create like 1 by n and something r by n term, right? So take the n term common from here. So what we get, limit n tending to infinity, summation from r is equal to 1 to 5n, and just I take the common 1 by n, and so it will be like 1 plus r by n. Now we all know that what we have to do. Now it's time to replacing. Now it's time to replace the thing. So how we can replace? We are actually replacing 1 by n to dx, r by n to x, and summation to integration. So let's do that. So what we get, integration of 1 by 1 plus r by n here. So it will like as x, and 1 by n as dx. Okay, what I done here, I just replace r by n to x. So at the place of r by n, I write it x, and 1 by n to dx. So I just write place of the 1 by n as dx. Now it's time for limit. How we calculate limit? So for lower limit, what we do? We do limit n tending to infinity, r by n, where r is the lowest term of this series, that is 1 by n. So when we solve this, we get the 0 for upper limit, limit n tending to infinity, r by n, where r is the maximum value of r, which is 5n. So 5n by n, this got cancelled and we get the value 5. So it varies from 0 to 5. And we all know that the integration of 1 by 1 plus x is nothing but ln 1 plus x. Now it's time to substitute the limit. So let's substitute it. So ln 6 minus ln 1, and we know that ln 1 value is 0. So our summation is ln 6. I hope you'll all understand this, what I'm trying to say, right? So let me tell you again what I'm doing here. I just use this theory. What you have to do, you have to first convert it to this series into summation of limit n tending to infinity, summation of r is equal to 1 to b, r is equal to a to b, 1 by n and f of r by n. And what I do here, we have to create r by n, right? So I just take the common n. So we get 1 plus r by n. And now it's time to replace the things. And what we do in replacing the things, we replace r by n to x, 1 by n to dx, and summation to integration. Now it's time for limit. देखो स्टेप बाय क्वेश्चन है. पहले हमें यहाँ से यहाँ नहीं है, देन इसको फिर रिप्लेस करना है, एंड देन हमें लिमिट. Now for limit, how to calculate the lower limit? So we are using limit n tending to infinity and r by n, where r is the lowest value of r. For lower, that means lower value of r. For upper limit, upper value of r, which is 5n. So 5n by 5. Now we get the, now our, this form is converted into this form. So we now we can integrate. We just learn the definite integration. So we are using the concept of that. I hope it's clear to you. Right. I hope like these things are clear to you. So now let's move on to the next problem. Like we have to learn its implementation, right? Okay, so let's take another example. Okay, so let's take the example number 2. So our example is something look like we are taking the limit and tending to infinity, and we're writing like 1 to the power 99, 2 to the power 99, 3 to the power 99, dot, 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 dot. Look at this, how big these number are, right? And we are dealing with so much big numbers. And there's like n to the power 100. So if you look at here, our 1, 2, 3, these are variable, right? So first we have to write this series into this format. I'm again writing like 1 by n summation of from r is equal to a to something b value and f of r by n. So first we have to write like in terms of r by n. So what we're doing here, I just follow the steps. I do nothing extra and nothing rocket science in it. I just follow this step, whatever uh, we have to follow. So limit n tending to infinity, we are writing summation. And first we have to write like r by n terms. So what I'm doing here, we can write it into like this form now. 1 by 1 by actually I'm trying to say like 1 to the power 99 plus 2 to the power 99, or we can write it in like n to the power 99 into 1 by n. We can write it in this form now. And then what you do, I just doing like 1 by n, 1 by 99 by n to the power 99. I just divide it. Separately, I divide it. So now this of the form like r by n to the power 99. So what I got from here, let me write it here. So we get from here like 1 by n, and here we get r by n to the power 99, where r is our varying from 1 to n. Now we reach to that form. Now it's time to follow the, if you go through this step now, oh, okay, let me elaborate it again, what I'm doing here. I just, actually this step is clear to you. Actually, this step is clear to you now, like what I'm doing. And after that, I just separate the each term. 1 by 99 n to the power 99 plus 2 to the power 99 by n to the power 99 and so on. Right? I hope you connect with this. Now, it's time to replace the thing. It's a replacing step. So what I do, I just replace 1 r by n to x, to the power 99, 1 by n to dx, summation to integration. Now it's time to limit calculation. Okay, so how we calculate the limit? So for lower limit, what we are doing limit n tending to infinity, r by n, where r is the r lower, which is 1. So 1 by n, limit n tending to infinity value is 0. And for upper limit, limit n tending to infinity, r by n, and the upper limit is n, so n by n, that value is 1. So it varies from 0 to 1. I hope you all know the integration of this. So let's integrate it and try to find the solution. Okay, so I hope you'll all calculated this. So this is the easy integration. But what is it? X to the power 100 by 100. We are just integrating from 0 to 1. So its value will be 1 by 100. Like I just insert the limit in this. I hope you'll all understand this, what I'm doing here. So let's look at our question once, and let's look at our summation value. Then you realize, look at this number, 1 to the power 99, 2 to the power 99, 3 to the power 19. They're big number. You can't even 2 to the power 99 means we are multiplying 2 99 times. 3 to the power 99 means we are multiplying 3 as 99 times, and then we are adding this whole thing 4 and ye n tak ja rahi hai, and which is tending to infinity. And what? And then, and it is just divided by n to the power 99. So what we get as a final answer? Just nothing but 0.01. How least value is that? That means कहाँ हम लोग कितनी बड़ी बड़ी digits को add कर रहे थे, but just the division by n to the power 99, we get the least value like 0.01. Okay, so somehow it's try to elude you, if there were 4 options given, some value were 1, some value were 2, some value were 3, 3000 into 10 to the power something like 65, like something value is given 3962, and one value is given is like 0.01. So if you look at this big number, so you directly choose this value, like this is the right answer. But when you solve this problem value looks big, but its solution is very less, and it is 0.01. I hope you'll all understand this and try to connect me what I'm trying to say. Anna, the data are big, the value looks very big, but we get the answer 0.01. Right? So always try to solve the problem by steps, irrelevant of going through like it's big data written. So I just go through the its की summation तो कुछ बड़ी value आएगी. ऐसा नहीं है. That's illogical thing. You have to follow the step whatever written or whatever you learn. Now, next move to the next problem. Okay, so let's move to the example number 3rd. So what is it? It is actually written limit and tending to infinity 1 plus root 2 plus root 3 plus root 4 dot 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 root under 2 and root under n minus 1, and it's divided by n root of n. Okay, so this is our series actually given. So now I have to integrate this or whatever. We have to use the definite integral as a limit of a sum property. It's not property, it's actually theory. So let's try to. So first we have to convert this into this form, which is like let me erase it. I'm writing actually limit, but it's okay. So we have to convert it into this form, like limit n tending to infinity, summation from r is equal to a to b 1 by n f of r by n. Our prior goal is to convert it into this form. First step is like that. So what I'm writing here, limit n tending to infinity, summation, we have to create like r by n. So what I'm doing here, if you look at here, 1 by n is already here. Like if we take this n is there, so it's already. So like what we get, 1 by root 2 dot 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 root n minus 1. Oh, let me write it in a clear way. So there will be like root of n minus 1 divided by root of n, right? I hope you'll all understand this, what I'm doing here. So there will be like 1 by n and then separate this thing. What we get, 1 by root n, root under 2 by n, dot 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 root under n minus 1 by n. So our we get this thing. So what we get here? We get the summation 1 by n, root under r by n, and where r is varies from 1 to n minus 1. Right? Now we convert our series into this format. Now what we have to do? We have to replacing step. So now it's replacing steps. I just tried this thing for you to understand in a clear way. What I'm doing, I'm just using the theory which I taught you just in just the beginning of the class. You have to learn how I solve and how I approach the problem. I do nothing extra. I just following the theory that I taught you already. So it's time to replacing step. So let's replace 1 by n by dx, r by n by x. So it will be like root x and summation by integration. Now it's limit calculation term. So when we calculate the limit here, what we actually, so the lower limit will be a limit n tending to infinity, r by n, where r is r lower, which is 1 by n, this is 0. Upper limit, limit n tending to infinity, r by n, our r is here, r upper, which is n minus 1 by n. So what we get the value 1. I hope you'll all know how to calculate the limit, right? You all are familiar with this now. Okay, so now it is from 0 to 1, and we all know that the integration of root x is nothing but 2 by 3 x to the power 3 by 2. 0 to 1, so what we get, 2 by 3. That means its value around 0.67. Okay, so our value will be 0.67, right? So I hope you'll all these things were clear to you. Okay, so now let's move on to the next problem. This is slightly, yeah, actually level 0 tha. So I hope you all learn the level 0 problem, which is actually based on basic implementation. Step by step I'm doing, right? And खुद से करोगे तो समझ में आ जाएगा कि क्या हो रहा है. Now it's time to move to the level 1. These problems are slightly tougher than the previous one. So, okay, let's see. So, is there something look like? Let me take the limit n tending to infinity, and there's like n plus 1, n plus 2, n plus 3, 3n divided by its power 1 by n. Okay, and there is like n to the power 2n. Okay, and its value is like something like that. Now you have to calculate what its limit, right? You have to calculate what its limit. Simply you have to calculate the limit, but it's not as easy as you think. It's actually based on the definite integral as a limit of a sum. But you raise a question, you told like I told you it's based on definite integral as a limit of a sum. But there is in numerator, there is no summation. There is product form. Like these terms are written with एक दूसरे के रिस्पेक्ट में ये प्रोडक्ट के फॉर्म में लिखी हुआ ना. इट्स नॉट रिटन इन दिस वे लाइक n plus 1 plus n plus 2. No, it's written in product form. But we actually learn today is like definite integral as a limit of a sum. So how to do this problem. It's if you go through our first step, look at here. Our series is given in form of summation. There is plus sign. So we can easily convert it into this term, like summation we can write, but there is product. So pause the video and let's try to think like how to approach this problem. So let me solve. Pause the video. My suggestion is pause the video and try to solve it by your, and if not, then watch the solution. Okay. So I'm gonna solve this. So look, we actually already learn things when we solving the definite integral. I think it's lecture number third or fourth. So whenever we have to convert, uh, I'm again saying whenever we have to convert uh, a product from summation, what we use actually log. It is very useful because it has a property like log of A, B, C with same base is equal to log of A, log of B, and log of plus log of C. This is a very important property. A, B, C were written in the form of product and we just take the log of it, we get in the form of summation. And what requires to us is to convert this uh, product form into the summation form. This is the thing that we have to need now. So what I'm trying to say is, let's use this concept, this logarithmic property concept to solve this problem. Okay, so let's start solving what I'm trying to say. So our given question is something look like, let me write it here again. Our given question look like limit n tending to infinity. Here is like n plus 1, n plus 2, and we can write this 3n as like n plus 2n. I think this thing, these manipulation are familiar and easy for you, right? So n to the power 2n, we can write into this form now, n plus 2n. So I just wrote it here. And to the power 1 by n, its limit is something else. Now what you have to take? Take log both side, right? What I'm doing here, I'm taking log both side. So what I get ln, L is equal to limit n tending to infinity log of n plus 1, n plus 2, n plus 2n divided by n to the power 2n to the whole power 1 by n. And we also know a property of log, like a to the power m is equal to m log a. So this thing, I think you are familiar with this thing. So we can write this power into a. So we like ln L is equal to limit n tending to infinity 1 by n. I hope you'll all understand this, what I'm doing here. Now we can write this product form into summation form. So how can we write? I write ln n plus 1 by n. Now this is n to the power 2n. So we can write this n to the power 2n as, so like n dot like 2n times, right? We can write this n to the power 2n as n dot 2n times, right? We are actually writing n to the power 2n as. So I hope you'll all understand this, what I'm doing here. Right now, okay. What you have to do, let me go through by here. So it will be like ln n plus 1 by and plus ln n plus 2 by n and dot ln n plus 2n by n. Now, if you look at here carefully, what we get ln n tending to infinity 1 by n. Let's do something here like 1 plus 1 by n plus ln 1 plus 2 by n. We just divided by n, right? We are doing nothing. Ln 1 plus 2. Oh my God. Because there is a 2n term, so n is cancelling both. All right. This is actually interesting. So let's move on to the replacing step because we get the r by n term. R is varying 1, 2 from n term. Like we can write it into 2n by n. And we already get the 1 by n. So now next step is our replacing step. Right? This step is replacing step. So what I have to do here, I have to just replace the summation by integration r by n by right. If I'm telling you, I have to just replacing step. What we do, r by n to x, 1 by n to dx, and then the summation by integration. So let's do that. So replacing step. So it will be something look like our. Let me write it here. So it will be something look like we are doing ln of L is equal to uh, 1 by n to dx, and there will be first you can write this into this term, then you have to replace. Okay. Actually, मैंने direct कर दिया, and I'm thinking I missed something. Summation of ln1 plus r by n, and our r is varies from 1 to 2. Okay. And we got this step, and now it's time to replace. So integration of ln1 plus x. Now it's time for limit. So let's calculate the limit. I hope you'll all get this. The lower limit is nothing but limit of n tending to infinity r by n, where r is r lower, which is 1 by n, so it's 0. And the upper limit is limit n tending to infinity r by n, where r is r upper, which is 2n. So it will be like 2. So we are integrating from 0 to 2. Now we know the integration of ln x. What is the integration of ln x? It will be like x ln x minus 1. So they are similar. The integration of ln 1 plus x is nothing but actually the integration is nothing but 1 plus x ln 1 plus x minus 1. Okay. So give me a moment. So ln 1 plus x minus 1. So I have to now just insert the limit here. Okay. So insert the limit here. So what we get, let's try to do here. So let me write it here from 0 to 2. Okay. So when we insert it, the limit here, what we get, first insert the upper, so 3 ln, and there will be like ln 3, right? And there will be like minus 1. Okay. When we insert the upper one, then it will be minus. I think I missed something. Yeah, there will be like this. And then minus, and when we insert the 0 here, so it will be 1. ln1 is 0, we all know that, and then there will be minus 1. So what we get from here? We get actually ln 3 ln 3 minus 3 and then plus 1. What? Plus 1, right? I hope you'll all understand this, what I'm trying to say. It will be like ln 27 minus ln e square we can write. Like ln e is equal to 1s, right? So ln e square is equal to, so we can write it in like ln 27 by e square. There will be like ln L is equal to, so the L is equal to 27 by, I hope you'll all understand this, what I'm trying to say. Right. So this problem is not actually easy problem when you do lots of problem, but it is a multi-step problem, because the first thing you have to learn is there is in the product form, right? But usually what we get in level 0, हमें बना बनाया मतलब summation के form में दी हुई रहती सिर्फ, and we just converted into summation form, and then what we do, we just replace, we just follow the replacing step and limit निकाल देते. But यहाँ पे एक स्टेप बढ़ गया, यहाँ पे we have to use the concept of log, क्योंकि यहाँ पे अपनी सीरीज जो दी हुई है वो प्रोडक्ट के फॉर्म में दिया हुआ है. एंड जब भी सीरीज प्रोडक्ट के फॉर्म में दिया हुआ है, there is only one way to convert product to summation, and this is the actually we are doing log ले लेते हैं दोनों साइड. तो हमने log ले लिया, एंड देन उसके बाद तो सारी स्टेप सेम थी. उसके बाद हमने आर बाई एन बना लिया एंड वन बाई एन क्रिएट कर रखा है हमने. एंड देन उसके बाद चीजें काफी इजी होती गई. क्यों? क्योंकि प्रीवियस स्टेप ही फॉलो हो रहा था. वी आर एक्चुअली मतलब कुछ नया स्टेप भी अपन फॉलो नहीं कर रहे थे. जो भी कर रहे थे प्रीवियस स्टेप ही फॉलो कर रहे थे. राइट. तो आई होप यू ऑल अंडरस्टैंड दिस व्हाट आई एम ट्राइंग टू. Okay, so let's move on to the next problem, which is also not an easy problem, but you can solve if you understand this kind of problem. Okay, so let me take that. So it is actually, let me, okay, it is actually based on same logarithmic concept because it's level 2. So, and we just, after that problem, we move to the level 3, level 2. So let's take the example here. So it is like limit and tending to infinity n factorial by n to the power n 1 by n. Okay, so we have to calculate its limit. So it is as simple. We are doing same thing. Let it be L. And actually, you know, the n factorial is nothing but n into n minus 1 into n minus 2 dot 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 1 tak. So let me rewrite here in a clear way that you can understand what I'm trying to say. N into n minus 1 into n minus 2 1 tak. And it will be like n into n into n into n into n dot 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 dot, actually n times. We can write n to the power n as and this to the power 1 by n. I hope you'll all understand this what I'm trying to say. And this is actually is equal to limit L. Now take the log both sides because this here the things is in product form and we have to convert it into summation. Then we can use the definite integration as a limit of sum. So what I'm doing here, take log both sides. So let me do it quickly. So what we get actually ln of L is equal to actually limit n tending to infinity 1 by n ln of there will be what we get actually here. So here we get 1 by n and there will be like ln 1 by n 2 by n dot 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 n by n. Like these things are clear to you now what I am trying to say. So it will like limit n tending to infinity 1 by n and there is the summation of ln r by n and our values varies from 1 to n. Look at here, r values from 1 to n. It will be like ln of L is equal to, now what we have to do now, it's replacing step. So in replacing step, what we do, we just do ln L is equal to okay from r by n to x 1 by n to dx and summation to integration. For limit now we can directly write the value is like r by n, so it will be 0, n by n that will be 1. I hope you'll get this. So ln L is equal to the integration of ln x is like x of ln x minus 1. Now try to substitute the here, insert the limit here. So let's substitute it. So what we get 1 ln 1 minus 1 and there will be 0. So what we get minus of 1. This term is also 0, but 1 into minus 1 is minus 1. So ln L is equal to minus 1. So what we get, L is equal to e to the power minus 1. So it will be 1 by. I hope you'll all understand this, what I'm trying to say, right? So this thing that we have to understand. Now let's move on to the level 2 problem, which is based on, देखो मैं कर क्या रहा हूँ ना, मैं तुम्हें जितने भी टाइप्स के प्रॉब्लम पूछे गए हैं या पूछे जा सकते हैं उसकी मैं तुम्हें टाइप बता दे रहा हूँ. एंड व्हाट यू हैव टू डू, तुम्हारा फील्ड ऑफ व्यू बस इससे इंक्रीज हो रहा है. लाइक यू नो हाउ टू अप्रोच दिस काइंड ऑफ प्रॉब्लम. लाइक हमेशा तुम्हें फेवरेबल कंडीशन नहीं मिलेगी ना एग्जाम में. यू हैव टू थिंक अबाउट इट. तो वो पहले से बता दे रहा है कि अगर प्रोडक्ट के फॉर्म में था, लाइक जो लेवल 0 था वो तुम्हें बना बनाया समेशन के फॉर्म में दी हुई थी, बस तुम्हें ये लिखना था एंड जस्ट यू हैव टू रिप्लेसिंग स्टेप एंड जस्ट यू हैव टू कैलकुलेट द लिमिट एंड यू गॉट द आंसर। बट इन लेवल 1 में क्या हुआ, ये प्रोडक्ट के फॉर्म में दी हुई थी, ये चीजें प्रोडक्ट के फॉर्म में दी हुई थी। तो सो यू यूज द कॉन्सेप्ट ऑफ लॉग and then you get and then you repeat the all previous step of level 0, so you get through the answer. Now it's level 2, we are using some concept of देखो level increase कैसे हो रहा है, we are including 2 or more chapter concept, that's why it's problem become more tougher. Problem tough कैसे हो रही है, I just use the concept of 2 and more chapter, that's it, उससे ज्यादा मैं कुछ नहीं कर रहा. So let me take the another example which is of level 2. So it is something like we have to calculate limit and tending to infinity 2n cn to the power 1 by n. I hope you all are familiar with this. This is actually combination. C stand for combination. I hope you'll all learn this thing in permutation and combination chapter. Right? आपने permutation and combination chapter में ये चीजें पढ़ी होंगी. And what is the value of NCR? Anyone? So this is like n factorial by n minus r factorial and r factorial. So this is the value of NCR. I hope you'll all know this. So, right. So NCR value is nothing but factorial of n by factorial of n minus r. And okay. Oh, I think, okay. Let me write it in a clear way. I think it's unreadable. So let me correct it. Okay. So the combination is, this is C is combination. And its formula is nothing but NCR is equal to factorial of n by factorial of n minus r by r factorial. So this thing I think clear to you. So now we have to calculate the limit of this. So let's try to use this formula. Okay, let's try to use this formula. So let's start it. Okay, so our limit L is equal to limit n tending to infinity. How can we write this? So it would be like 2n factorial by n factorial into n factorial. Use this formula. I'm just using this formula. I'm doing nothing extra. I'm just using the combination formula. So we get to the result of this. Now what I have to do? Look at this. This is actually the form of product. अभी हमने n factorial पढ़ा ना. n factorial just अभी बताया था. n in मतलब 1 into 2 into dot 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 n terms तक. Just अभी मैंने इस चीज को बताया है. बताया नहीं बताया? Okay. So what you have to do? It's actually written in form of product. So take log both sides, obviously. And so it will be like ln of L, and it will be like limit n tending to infinity. This power comes in base, so 1 by n, ln of 2n factorial divided by n to the power 2n, right? And minus ln of n factorial by n to the power 2, right? And then it will be like ln of L. देखो यहाँ तक तो मैंने बस कर दिया, and then I'm just following the steps. So it will be like ln of L is equal to limit n tending to infinity. I have to now create r by n term because 1 by n is already created. So it will be something like, if you look at carefully, what it's written, 1 into 2 into 3 dot 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 2n terms तक, and it will be n dot कब तक 2n terms तक 2n times minus ln of 1 dot 2 dot 3 dot dot n terms, and it's again 1 dot 2 dot 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 n times that, and it will be like n dot n times, and it's again n dot n times. So it will be something like written as ln L is equal to, now directly converted into integration form. I hope you will all पिछले आधे घंटे से अपन यही काम कर रहे हैं, so it will be clear to you. So in first step, our limit varying from 0 to 2, ln of x minus 2, and our limit varying from 0 to 1, and it's 2 times, so it will be 0 to 1, ln of x dx. It's dx. So our ln of L is equal to, when we integrate this, what we get here? X of ln x. So x of ln x, x of ln x minus 1. So try to substitute the limit here. 0 to 1 ln of x. Why are you doing the same thing 2 times? It will be like x ln x minus 1. And we are inserting the limit from 0 to 1. So on inserting the limit, what we get? We get ln 4 minus 2 plus 2 ln L. So here we get this 2 to get cancelled. So here we get L is equal to 4. This is our final solution. Right. I hope you'll all understand this, what I'm doing here. So let me tell you again. So this is a level 2 problem. So I am including one more chapter concept. And what that concept is, we are using the permutation and combination chapter concept. We are including the permutation and combination chapter concept in calculus. मैंने क्या करा? मैंने बस कॉम्बिनेशन के कॉन्सेप्ट इसमें जोड़ दिया, इससे ज्यादा मैंने कुछ भी नहीं करा. And I'm using the simple concept of combination. So now it's, अब ये जो आया फॉर्म, ये प्रोडक्ट के फॉर्म में आ गया. ये प्रोडक्ट के फॉर्म में आ गया, मतलब ये लेवल 1 के फॉर्म में आ गया, क्योंकि लेवल 1 के फॉर्म में क्या था? प्रोडक्ट के फॉर्म में था. प्रोडक्ट के फॉर्म में आ गया. अब यहां से जो भी स्टेप अपन कर रहे हैं, यहां से इट्स ऑल ऑफ लेवल 1. देख रहे हो सीढ़ी कैसे चल रहे हैं? लेवल 0, लेवल 1. लेवल 1 में वी आर यूजिंग द कॉन्सेप्ट ऑफ लेवल 0 and adding some concept, and in level 2 we are using some other chapter concept and then follow the all step of level 1 followed by level 1. So these are the things that you have to go through it, right? So this is the last topic, which is the definite integral as a limit of a sum. Okay, so from so there is the end of the chapter definite integration. So by tomorrow's lecture we are actually gonna do जो भी हमने इंटीग्रेशन अभी तक पढ़ा है, लाइक इंडेफिनिट इंटीग्रेशन पढ़ रखी है हमने, डेफिनिट इंटीग्रेशन पढ़ रखा है. अब इन दोनों का लाइक थ्योरेटिकल तो हमें सॉल्व करने आ गया. नाउ इसकी रियल लाइफ एनालिसिस देखेंगे, हाउ आई यूज दिस इंटीग्रेशन इन आवर रियल लाइफ एंड इट्स एप्लीकेशन. सो कल से we are going to start our new chapter, which is application of integral. Like हमने जो भी पढ़ रखा है उसकी कुछ रियल लाइफ इंपॉर्टेंस तो होगी, या फिर हम यूं ही बस ऐसा इंटीग्रेट कर रहे होते हैं? नहीं, उसकी एक रियल लाइफ में यूज है, एक एप्लीकेशन है, बहुत सारे एप्लीकेशन है, नॉट अ सिंगल, मतलब वेरियस अलग अलग फील्ड में अलग अलग तरीके से इस्तेमाल कर रहे होते हैं हम लोग. सो वी आर एक्चुअली वी हैव सम बाउंड्रीज जो भी सिलेबस में दी हुई हैं. सो वी आर डीलिंग विद इट. सो मैं एक हिंट दे देता हूँ, वी आर गोना लर्न फर्स्ट एरिया, जो हमने डेफिनेट के फर्स्ट लेक्चर में बताया था कि व्हाट्स द ज्योमेट्रिकल मीनिंग ऑफ इंटीग्रेशन. सो मैंने बताया होगा द ज्योमेट्रिकल मीनिंग ऑफ इंटीग्रेशन इज द नथिंग बट एरिया. अगर आपको दिक्कत हो रही है देन प्लीज वॉच द लेक्चर नंबर 1 ऑफ डेफिनेट इंटीग्रल. तो वहां पे आपको समझ में आ जाएगा, एंड देन यू connect with the application of integral. So that's all for today. Thank you very much. कल की क्लास में अपन नई चीजों की सीखेंगे, which is application of integral. Thank you.